This is a grasshopper. It can leap 20 times its body length in a single jump. It does this by storing energy in its legs like a spring. Here's how it works. When the grasshopper is resting, its legs are straight. But when it wants to jump, it bends its legs and stores up potential energy. Then it releases that energy and springs into the air. And because its legs are so strong, it can jump really, really high and really, really far. In fact, there's only one animal that can jump higher than a grasshopper, and that animal is a frog. But frogs have to be at least twice the size of the grasshopper to be able to jump higher. Otherwise, they just don't have enough power. And it's not just frogs. In general, bigger animals can jump higher than smaller animals. That's because there's a basic physics rule that says that the bigger an animal is, the more force it can exert with its muscles. More force equals more jump. But grasshoppers aren't just big. They're also really, really good at leveraging the physics of their bodies to maximize their jump. And part of what makes them such good jumpers is their exoskeleton. Because it's rigid and lightweight, it allows the grasshoppers to store a lot of energy without adding a lot of weight. And then there's their leg muscles, which are made up of super long muscle fibers. These fibers are really efficient at converting chemical energy into kinetic energy, which is the energy of motion. The longer the muscle fibers, the more potential energy the grasshoppers can store in their legs. And the longer the time that they can store that energy for, the more force they can exert when they release it. But there's another reason why grasshoppers can jump so well. They have elastic tendons in their legs that help them bounce back even higher. When a grasshopper jumps, it lands on its feet and then immediately bends its legs again, ready for its next jump. The elastic tendons in its legs store up potential energy from the impact with the ground. And then when the grasshopper hops again, that potential energy gets released, giving it a little extra boost. These special adaptations allow grasshoppers to jump 20 times their body length. That's the equivalent of a human jumping about 24 feet in the air. And some species can actually jump even higher than that. Take the gerboa, for example. This tiny desert-dwelling mammal has super long, powerful hind legs that allow it to jump over 3 feet in the air. That's the equivalent of a human jumping over a double-decker bus. And the jerboa can do this because it has specialized muscle fibers in its legs that are tuned for explosive movement. Of course, these incredible jumping abilities aren't just for show. They're an important part of the grasshopper's life cycle. Being able to jump high and far allows them to escape predators. It also helps them find new food sources and survive in a wide range of habitats. Frogs, on the other hand, use their jumping ability to hunt. Their long, powerful legs allow them to leap onto their unsuspecting prey and snatch them in their sticky tongues. But no matter why they do it, the fact remains that frogs and grasshoppers are two of the best jumpers in the animal kingdom. So the next time you see a frog or a grasshopper, take a moment to appreciate their incredible jumping abilities. You can bet they're reusing physics to their advantage to make a big splash or a big leap. Specimen use made possible by a University Museum of Zoology.